This last section is on modeling, but this time it's the absolute value function. So what is the general form of an absolute value equation? It is the absolute value of ax plus b equals k, where a is your slope and b is your y-intercept, and it will equal a constant. So remember that absolute value means the distance we are away from zero. So inside the absolute value can be both positive and negative numbers. In other words, the absolute value of 7 is 7, but also the absolute value of negative 7 is 7. You see how inside the absolute value is both a positive and a negative. We are going to solve these symbolically, which means to do your algebra, graphically, which means to make a graph, and numerically means to look at a table. So first, when you are doing these graphically, to graph an absolute value, you will first find the x-intercept of the absolute value part. So in this case, my x-intercept of the absolute value part would be 6x minus 3 equals 0. So I will add 3. 6x equals 3, divide by 6. X equals 1/2. So my x-intercept is 1/2, 0. So I'm going to plot 1/2, 0. Then you will count your slope, both left and right. Since it is absolute value, I can go to the left, which would be negative, and to the right, which would be towards the positive direction. So I'm going to count my slope. My slope is 6/1. So I'm going to go up 6/1 to the right or to the left. And I'm just going to do that one more time so that I can get a nice straight line. So there's my absolute value. So there's my y1. Then I'm going to do 15 as my y2. So here's my y equals 15. And if I look and I bring these down to the x-axis, I get 3. And I get -2. So I get -2 union 3. Because it is equal, I just have the one value on each side. Now, I just want you to pay attention closely. The absolute value is less than c. So remember, both positive or negative can go in the absolute value. So if I take the positive of all that, I would get ax plus b is less than c. So that gives me c over on this side equal. If I take the negative of that, I would get ax plus b. When you divide by a negative, it flips it as -c. So -c is to the left. So it says my values are left of c, so that's open parenthesis to the left, and my values are right of -c, so that's an open parenthesis to the right. So that means I have from -c to c. Notice that when it is less than with absolute value, I am in between my two values. Now I'm going to do the same thing, but let's look at it for greater than. So again, a positive or a negative can go in here. So I put a positive value and a negative value. Well, when I divide by positive 1, I get my value is greater than C. When I divide by a negative, I get my value is less than negative C. So again, I have C, and negative C would be to the left of it. This one says my value is right of C. So notice it opens to the right. Then it says my value is left of negative C. So it'll open to the left. So if you look at this, you can see I have the values to the left of negative C and to the right of C. So in interval notation, it would be from negative C, from negative infinity is furthest to the left to negative C, union positive C to positive infinity. When it is greater than, I should have a disjoint set. So let's solve a few algebraically. So I know I can put a positive or a negative in here. So the positive of 4x minus 9 or the negative of the quantity 4x minus 9. Now I am going to distribute this positive 1 throughout, and I just get 4x minus 9 is less than or equal to 21. I'm going to add 9. 4x is less than or equal to 30. I'm going to divide by 4. And I get x is less than or equal to 15 halves. I'm going to distribute this negative. So I get a negative 4x plus 9 less than or equal to 21. Subtract 9. Negative 4x less than or equal to 12. Divide by negative 4. When you divide by a negative, it flips your sign. So x is greater than or equal to negative 3. So if I draw the graph of this, I have negative 3 to the left. I have 15 halves to the right. This says left and equal of 15 halves. So it'll be like this. Brace. This one says my values are greater than or equal to negative 3. So it'll open to the right. So that means I have from negative 3 to to positive 15 halves in braces in between. Again, I was less than, so I better be in between. Okay. Should we try one more? Positive or negative. So the positive would be 3x minus 2 greater than 18. The negative of 3x minus 2 would be greater than 18. The positive is just as it is. So I'm going to add 2. And I get 3x is greater than 20. Divide by 3. X is greater than 20/3. Negative 3x plus 2 is greater than 18. Subtract 2. Negative 3x is greater than 16. Divide by negative 3. When I divide by a negative, my sign switches. X is less than negative 16/3. So when I draw this graph, negative 16/3 is to the left of 20/3. This says greater than 20/3. So opening to the right on 20/3. This one says less than negative 16/3. So opening to the left. So furthest to the left, I have negative infinity to negative 16/3, all in parentheses, union 20/3 to positive infinity. Greater than should be a disjoint set. at the ends. Okay, solve graphically. So first I find my x-intercept. So x minus 3 equals 0. So x equals 3. 3, 0. I'm going to plot. Then my slope is 1. So up 1 over 1. So I'm going to get a few of those. Oh, let's try that again. There we go. And then I have 5. So here's my 5. So if I take this down to the x-axis, I see 5, 6, 7, 8, and I see -2. And it says, where does the graph go greater than 5? So this is greater and this is greater. So it's happening out here and out here. So that would mean from -infinity to -2. And it was an equal bar, so it would be a brace on the -2, union, a brace on the 8 to positive infinity. Again, greater than should be a disjoint set, so I do see I get that. Now, in an authentic real-life situation, absolute value stands for tolerance. Absolute value is equivalent to tolerance. So, an example we have here is on an assembly line. The manufacturer has 0.6 ounce tolerance. So that means basically the bottles of dressing can either be half an ounce over or half an ounce under. On a bottle that is 16 ounces, write the absolute value. So the absolute value will be less than or equal to 0.6. That is my tolerance. So that is what my absolute value is equivalent to. I have a 16-ounce bottle, so x minus 16. Whatever I have, I'm going to subtract from the 16. It says solve it. So if I have the positive of that and the negative of x minus 16. So x minus 16 is less than or equal to 0.6. Add 16. I get x has to be under 16.6 ounces. If I do my negative x plus 16 less than or equal to 0.6, subtract 16. Negative x less than or equal to negative 15.4. Divide by -1. Dividing by a negative flips my sign. So I see 15.4 is to the left of 16.6. I am less than 16.6 and greater than 15.4. So that means I will have to have my bottles to make it off the assembly line be between 15.4 ounces and 16.6 ounces of salad dressing. So that does make sense.